Hello and welcome to Scholar Fedu. This is our JAMB prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2016. This is the second part of the recording. We are going to be looking at the last 20 questions for this year. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. Alright, first question here. In the series AC circuits shown above, the potential difference across the inductor is V. Okay, the effective voltage is so the effective voltage will be given as V squared equals, since we have in this circuit we have a resistor, we have only a resistor and an inductor. The effective voltage V is going to be V squared equals the voltage across the resistor square plus the voltage across the inductor square. So V squared will be equal to voltage across the resistor, which is 6 volts. We have 6 squared plus voltage across the inductor, 8 square. So here we have V squared is equal to 36. That's 6 raised to power 2. 6 times 6, 36 plus 8 raised to power 2. 8 times 8, 64. 36 plus 64 is equal to 100. That is, we have V squared is equal to 100. To get the value of V, we take the square root of both sides. So V will be equal to the square root of 100, and that is 10 volts. Next question on sound wave. In a closed organ pipe producing a musical note, an antinode will always be produced at. So here, okay, so we have the nodes and the antinode. The nodes are this point N and the antinode at the point A. The node is the point of minimum displacement, while the antinode is the point of maximum displacement. And as you can see here, the antinode here is produced where? In the middle. Okay, it's produced at the middle here. Next, on heat and heat calorimetry, what happens when a certain quantity of pure ice is completely changed to water at 0 degrees Celsius? Okay, the latent heat will be absorbed. Alright, the latent heat will be absorbed. That's one. The mass will remain the same. Okay, it will remain constant, but the volume is going to change. The volume is going to decrease. You can think of ice as puffed water. Okay, like think of it as enlarged water or inflated water. So what happens when ice melts is that the size is going to reduce. Okay, the size will reduce, so the volume or the size is going to reduce, but the mass will remain the same thing. Okay, and latent heat would be absorbed. Next, if two parallel conductors carry currents flowing in the same direction, the conductors will, there's going to be an attraction between them. Okay, an attraction will be set up between the conductors. They will attract each. Next, on optics, which of the following correctly explains why a green light appears green in a bright daylight? Okay, so the color of a body is the light that it reflects. Okay, the light that it reflects. Now a green leaf is going to appear green because it absorbs all the colors of the sunlight except for the green. Okay, all the other lights, all the other colors are absorbed except for the green. So it is that green that appears. Also, it reflects only the green component. Like I said, the others are absorbed. It is only the green that is reflected. So you have I, and I. The other, it absorbs only the green. It absorbs the green. That means it will not be green. It will be another color. Okay, besides green. So you have I, and I. That is all colors are. Next, on current electricity, which of the following factors has no effect on the EMF of a primary cell? The size of the cell does not affect its EMF. Next, on sound wave, when the bottom tip of a vibrating tuning fork is held in contact with a wooden box, a louder sound is heard. This phenomenon is known as That sound that is heard is due to a phenomenon that we call resonance. Okay, resonance. This occurs when a body is set into oscillation or vibration. That is when a body is made to vibrate at its own natural frequency due to the impulse of vibrations that it receives from an external body, okay, that is vibrating at the same frequency. All right, so the loud sound that is heard with the tuning fork brought in contact with a wooden box is due to resonance. Next, on laws of motion, a particle of mass m, which is at rest, splits into two if the mass and the velocity of one of the particles are m and v. Calculate the velocity of the second particle. Alright, the mass, let the mass of the original object be capital M. Let's represent as capital M. Okay, now if that mass now splits into two, and one of those particles, the mass of one of those particles is m, that means that the mass of the other particle, the second part, is going to be m minus m. Okay, what I'm saying is, let's say that the mass of the original particle is 10. That particle now splits into two, and the mass of one of those particles that is splitted into is 3. In order to get the mass of the other particle, we will subtract that 3 from the 10, which is the original mass of the substance where it came from. So that means that substance is splitted into two, one of mass 3 and another of mass what? 7. Okay, so that's how it will be. So that's what is happening there. So we've represented the mass of the original particle as capital M, and the mass of one of the particles that is split into as m, small m. So the mass of the other particle is going to be, you subtract the mass of this small particle from the original particle, so you have m minus m. Okay, now the momentum of both particles is going to be equal because this is the same force that was exerted, okay, on them during that split. Okay, that means that the mass, the momentum, okay, is mass times velocity. So the momentum of the big particle, okay, of let's say the other particle, let's say that the momentum here, they said the velocity of one of the particle is m and v. Let us represent the velocity of the other particle as capital V. Okay, the second particle as capital V. Alright, so that means that the momentum of that big particle is going to be the mass of the big particle, or of the other particle rather. Let me not use big, okay, because there's nothing to suggest that the particle is bigger than the other one. Okay, but the mass of that other particle is going to be m minus m, the mass of the original particle minus the mass of one of those substances that is split into, times the velocity of that other particle, equal to mv. So the velocity of the second particle will then be, how do we get it here? We are going to divide both sides by this m minus v, so that will become mv divided by m minus v. So you have mv over m minus v. M minus m rather, m minus m. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on electrolysis, the electrochemical equivalent of silver is given as 0.012 grams per coulomb. If 36.0 grams of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be. So we recall from Ohm's law that we have M to be equal to ZIT from Ohm's law. That is, the mass of the element deposited is equal to Z, the electrochemical equivalent, times I, the current, times the time. So what we are looking for here is the current, right? So you're given the mass of the silver as 36, so you have 36 is equal to Z, the electrochemical equivalent of the silver is 0.0012, so we have that, times I, the current, which is what we are looking for, times, they gave us the time in minutes, 5 minutes. We need to convert it to seconds. So how do you convert from minutes to seconds? We multiply by 60. So 5 minutes is going to be 5 times 60 in seconds. Now by the time you multiply is 0.0012 by 5 by 60, you are going to get is 0.36. So times I, that will be 0.36 I. So to get the value of this I here, we are going to divide both sides by 0.36. So 36 divided by 0.36 will give us 100 ampere. So you have 100 ampere here. Okay, next on electromagnetic induction. The principle of operation of an induction coil is based on Faraday's law. So we have what we call the Faraday's law of electromagnetic induction, which states that a changing or varying magnetic field will induce an EMF in a conductor or a loop that is placed in its field. So we have Faraday's law, and that is what the principle of operation of an induction coil is based on. Next, on nuclear physics, a radioactive sample initially contains n atoms. After 3 half-life, the number of atoms that have disintegrated is. Alright, so the initial number after n half-lives, the initial fraction of the particle before any disintegration, that is 1. Okay, let's take it as 1, like a whole as 1. Now after n half-life, we are going to have 1 over 2n of capital N. This capital N is the original number of atom that it contains. Okay, after the first half-life, we are going to have 1 over 2 of this thing here. Okay, after the second one, we are going to have 1 over 2 of 1 over 2 of this, and that will be like 1 over 2 raised to power 2. Do you understand? So after n half-life, you can just say generally that will be 1 over 2 raised to power n of the original number of the atom. Now, so after n half-life, this is what is going to be left. Okay, this is what is going to be left, 1 over 2 raised to power n of this n. That's what we are going to have. Now if it's now 3 half-lives that we have, meaning that we have n instead of n half-life, we have 3 half-lives, then we are going to have what, 1 over 2 raised to power n, where our n now is what, is 3. Okay, so we are going to have 1 over 2 raised to power 3 of n. That will be 1 over n of 1 over 2 raised to power 3 means 2 times 2 times 2. So that is 8. So you have 1 over 8 of n. That's 1 over 8 times n, and that will be n over 8. So you are going to have n over 8 of the original atom. Okay, the first one is the number of atoms that have disintegrated. Okay, now this is what is going to be left. Okay, this will be left. How do you now get what has disintegrated? That will be 1 minus what is left, 1 minus n over 8, and that is going to give us, n rather, n 1n minus n over 8, and that will give us 7n over 8. Next, on temperature measurement, mercury is suitable as a barometric fluid because that's because it is denser than water. Okay, it is denser than water. It has a higher density than water. Next, on nuclear physics, which of the following features is not characteristic of natural radioactivity? Okay, this is not characteristic of natural radioactivity. That the radioactivity is affected by electric and magnetic field in the surrounding. No, radioactivity, okay, is largely independent of this. Okay, the first one there is, let's explore the other option. Radioactivity is a nuclear phenomenon, is correct. What it means is that it involves nucleus of atoms. Okay, in regular chemical reaction, what goes into reaction is the electrons, but in nuclear reaction, okay, like radioactivity, it is the nucleus that goes into reaction. So it is a nuclear phenomenon. Also, that radioactivity is excited by only by elements of mass number greater than 206. Every nucleus, okay, by every nucleus or elements having mass numbers greater than 206 and atomic number greater than 83, they are every nucleus, and those are the atoms that can undergo radioactivity. All right, and the last one there, that the radiations from radioactivity, during radioactivity, there are 3 radiations: the alpha rays, the beta rays, and the gamma rays. Okay, or the alpha particle rather, the beta particle, and gamma rays. So these are products of radioactivity. Energy also accompanies that process. Energy is also released in the process. So what we have here is the odd one out here. Okay, this is not characteristic of radioactivity. It is not affected by electric and magnetic field. Which of the following is a correct explanation for the inertia of a body? That is A. A defines inertia. It is the reluctance of a body at rest to start moving, okay, or the reluctance of a body in motion to stop after it has begun to move. Okay, so this combines these two already. The reluctance to this is even readiness, okay, which is not the case. Okay, inertia is reluctance. It's reluctance, basically reluctance to move or to stop. Okay, and that is well summarized in this here. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next, if the force on a charge of 0.2 coulombs in an electric field is 4 Newton, then the electric field intensity of the field is. Alright, here we have the charge Q as 0.2 coulombs and the force as 4 Newton. The electric field intensity is equal to the force, the electric force over the charge. Okay, so you have the electric force as 4 divided by the charge 0.2. 4 divided by 0.2, that is 20 newtons per coulomb. Next question in elasticity. The point beyond which a stretched spring does not return to its original length is called the. That is called the elastic limit. Okay, the elastic limit. That is the point above which, okay, or beyond which a stretched material or object will not return to its original length. But if the object is released, even at that elastic limit, it can still regain its original form. But if it is stretched up above the elastic limit, okay, then it does not return to its original length. Next, on optics, which of the following statements is applicable to a real image formed by a concave mirror? Alright, it can be observed on the screen. Why? Because the image formed by a concave mirror, they are real image, and real images are produced in front of the mirror. A concave mirror can be made to produce virtual image. Alright, that is true. That is if you have the object between the principal focus and the pole of the mirror. However, in most cases, besides that, it forms a real image, so that image can be focused focused on a screen. Next, that it is inverted. Okay, yes, the image is always inverted and in front of the mirror, unless it's a virtual image under the condition that has been stated already. It only seems to exist is wrong. We say it only seems to exist, that means we are saying that the image is virtual. Okay, it's a virtual image that is what we call like a seeming image. Okay, a seeming image. It's an image that is formed from the apparent conversion, the apparent divergence of light ray, okay, or convergence, as the case may be, whether you are dealing with a lens or a mirror. So if you say that it only seems to exist, that means you are saying that the image, okay, you are saying that the image is what is virtual. Okay, and already from the question they even said applicable to a real image, so you can forget even the case of when the object is between the principal focus and the pole. You can even leave that out because the question is already restricted. So the real image, and real images are formed, yes, from the actual, okay, from the actual convergence of light ray. Okay, the apparent convergence of light ray will form virtual images, but real images are from the actual convergence. So I and IV are correct. Real images, they actually exist, not seem to exist, so this is wrong. Next, which of the following does not cause a reduction of the surface tension of water? Grease. Okay, grease. The presence of soluble impurities increase surface tension. Okay, it increases surface tension. Next, on thermal expansion, in what range of temperature is the expansion of water anomalous? Anomalous meaning abnormal. So water has an anomalous behavior, water and some other liquid, and that is that generally when a liquid or a solid is heated, it is going to be expanding, its volume will expand, will increase, it expands. And when it cools, when it loses temperature, it contracts, meaning it becomes smaller. However, water has an anomalous behavior within the range of 4 degrees Celsius to 0 degrees Celsius, in that as the temperature falls, okay, as the temperature falls from 4 degrees Celsius to 0, instead of it contracting, instead of it becoming smaller, it begins to expand, okay, turning into ice, it begins to expand. So the range of temperature where we have that anomalous expansion is from here to here. Okay, as it falls, okay, as it falls from 4 degrees Celsius to 0 degrees Celsius, the water begins to puff up, okay, it becomes bigger. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.